When we close our eyes at night, lost in dreams, reality often blurs. But what if our waking life isn't as real as it seems? Scientists are grappling with this exact question, and their discoveries are nothing short of mind-boggling. The idea that the universe might not be real as we understand it isn't just science fiction. It's an unsettling possibility backed by groundbreaking experiments in quantum mechanics and bold new theories. To understand why some scientists believe our universe isn't locally real, let's break it down. In physics, something is considered real if its properties exist independently of whether they're being observed. For instance, an apple remains red whether or not someone is looking at it. Local means that objects can only be influenced by their immediate surroundings, and nothing can travel faster than light. But when we dive into the quantum realm, these assumptions start to crumble. This is where things get weird. Scientists discovered a phenomenon called quantum entanglement, which suggests that particles can be linked in such a way that changing one instantly affects the other, no matter how far apart they are. Let's start with a famous thought experiment called the Einstein-Podolsky-Rosen (EPR) paradox. Imagine two people, Anna and Luke, sitting on opposite sides of the universe. A pair of coins is sent to each of them, spinning wildly in transit. According to quantum mechanics, we can't predict which side the coin will land on. It's purely random. However, here's where it gets strange. When Anna observes her coin and sees heads, she instantly knows that Luke's coin will show tails, no matter how far apart they are. This isn't a lucky guess. It happens every single time. The odds of predicting such outcomes even 200 times in a row are astronomically small, about 1 in 10 to the 60th power, a number larger than the total atoms in the solar system. This phenomenon is known as quantum entanglement, and it's like the coins share a secret telepathic connection. Even though Anna and Luke are separated by billions of kilometers, the state of one coin determines the state of the other instantaneously. This defies our common sense and even Einstein's theories of relativity, which state that nothing can travel faster than light. Before quantum mechanics, scientists believed the universe was deterministic. Everything followed predictable laws. If you knew all the properties of a system, you could calculate its past and future with perfect accuracy. But quantum mechanics shattered this certainty. Take radioactive decay as an example. If you place radioactive atoms in a container, you can predict how many will decay over time, but you can never determine which specific atoms will decay. The process is fundamentally random. Similarly, when particles are fired through a double-slit experiment, they create an interference pattern that's predictable in aggregate but random in detail. Einstein wasn't a fan of this randomness. He famously remarked, "God does not play dice with the universe." He believed there must be hidden variables, unknown factors influencing these seemingly random outcomes. However, experiments conducted by physicists like John Clauser, Alain Aspect, and Anton Zeilinger, who won the Nobel Prize for their work, proved that these hidden variables don't exist. In essence, particles don't have properties like position or momentum until they're measured. Is reality an illusion? If particles don't have definite properties until they're observed, what does that mean for our reality? Let's revisit the concepts of real and local. If the universe isn't real, objects don't have inherent properties unless they're being observed. And if it isn't local, things can influence each other faster than the speed of light. This challenges everything we thought we knew about the physical world. It's like the universe is a giant magic trick, revealing its secrets only when we decide to look. But if reality isn't what it seems, what is it? One intriguing theory suggests that our universe might be like a digital simulation. Just as a TV screen is made up of tiny pixels, reality might be built from the smallest possible units, called Planck lengths. these are unimaginably tiny. Physicists have proposed that these pixels of reality could be shaped like tetrahedrons, three-dimensional triangles. When combined, they create a structure known as a quasi-crystal. This quasi-crystal might be the fundamental building block of the universe, projecting higher dimensional patterns into the three-dimensional world we perceive. This idea is eerily similar to how a digital image is created by projecting data onto a screen. If the universe is a projection, it raises an even bigger question: who or what is running the show? Another mind-bending theory suggests that reality is tied to consciousness. In this view, the universe doesn't exist in a definite state until it's observed. This idea aligns with the famous double-slit experiment, where particles behave like waves when unobserved, but act like particles when measured. If consciousness shapes reality, then the act of observing the world might create it. This notion has profound implications, suggesting that our minds play a far more significant role in the universe than we ever imagined. The simulation hypothesis: if the idea of consciousness shaping reality sounds too abstract, consider the simulation hypothesis. Proposed by philosopher Nick Bostrom, it suggests that our universe might be a sophisticated computer simulation created by an advanced civilization. Think about video games. Characters in a game perceive their world as real, even though it's just lines of code. Similarly, if we're in a simulation, everything we experience, light, sound, touch, is a product of programmed algorithms. One potential clue is the speed of light. It's a universal constant, like a maximum processing speed for our simulated reality. Scientists speculate that if we could overload this cosmic computer, we might see glitches or anomalies that reveal the simulation. Real-world experiments. Scientists are actively testing these theories. For instance, researchers at the University of Maryland successfully simulated the nucleus of a helium atom using quantum computers. While this might seem small, it's a huge leap towards simulating larger and more complex systems. If we ever manage to simulate a fully conscious being, it would almost certainly confirm that our own reality could be simulated. However, this raises ethical and philosophical questions. If we're just part of a simulation, does our existence have meaning? Or are we simply entertainment for some higher dimensional beings? What does it all mean? The idea that the universe isn't real or is a simulation might sound unsettling, but it also opens up fascinating possibilities. If reality is a projection, we might one day learn to manipulate it. If consciousness shapes the world, then our thoughts and perceptions hold incredible power. And if we're living in a simulation, perhaps we can discover who or what is behind it all. So, where does that leave us? Are we cosmic avatars in an elaborate game, or are we pioneers on the brink of understanding a deeper truth about existence? While we don't have all the answers yet, one thing is clear. The universe is far stranger and more mysterious than we ever imagined. As we continue to explore these mind-bending theories, it's worth remembering that science is just about finding answers. It's about asking the right questions. And when it comes to the nature of reality, the questions might be just as important as the answers. What do you think? Is the universe a grand illusion, a digital projection, or something even stranger? Let us know your thoughts in the comments below. The journey to uncovering the truth has only just begun. If you enjoyed this journey through the cosmos, don't forget to give us a thumbs up and share this video with fellow space enthusiasts. Your support helps us continue exploring the wonders of the universe. Be sure to subscribe to Spacified and hit that bell icon so you never miss an update on our latest discoveries. Dive deeper into the mysteries of space by checking out our other videos, and let's keep the adventure going on together.